Hello, I still have nothing to show to you. Hope this will change soon, at least since June many European countries promised to open the borders, so we'll see. And that's why I decided today to try to explain few technical aspects related to the personal audio. Definitely it won't be the best explanation. On YouTube there probably are much better explanations, much more visual and so on, but anyway, let's talk about the few frequency asked questions. And first one that I'd like to address is the question is what are all those connectors made for, what is the difference between line out, coaxial out, balanced out, and so on and so forth. But first of all, let's talk a little bit about the process of digital to analog convertering and vice versa. I will try to simplify it as much as possible, maybe even oversimplify sometimes, but anyway. So let's say everyone knows that sound is a sonic wave. So it's some oscillations like higher, lower, or something like that. Usually it can be splitted as a combination of different sine waves using Fourier transform, and this doesn't look like sine wave, but anyway, when we have some air movement, it's grabbed by microphone, and then microphone produce some current changes that reflect these waves of sound. And then this analog signal comes to the analog to digital converter. And what does analog to digital converter do? It splits this signal to smallest, tiniest periods of time. So with equal periods, usually you know this figure, it's 44.1 kilohertz, so 44,100 times per second. It just measures the level of this sound. So we've got some figures like here, we've got, let's say, -2, then -2, then +3, and so on. But of course it's not measured like I do in -2 or +3 or something like that. It's determined by another parameter called bit depth. So two parameters of the signal sampling. First one is the frequency, how many times per second we measure this level of signal. And second one is how many bytes we are spending to store this information. So if we use 1 byte, it means that we can decode signal from 0 to 255. So some relative difference. And that leads us to another parameter that's called dynamic range. So what is the difference between the highest and lowest signals that we can perceive? Our ear is pretty sensitive, so our ear's dynamic range is about 120 to 140 decibels. So if you're interested what decibel is, it's the logarithmic unit of measurement for the difference of levels. You can look at the Wikipedia if you need more details. But this parameter for our ear is not precise, because somewhere at about 120 decibels and higher we have a risk of constant hearing loss, and 140 decibels and higher causes pain and other really unpleasant effects. So 1 byte is not enough to store this information. So 8 bits. Usually the most commonly used is 2 bytes or 16 bits. And 16 bits gives actually 96 decibels of dynamic range. So it's a pretty poor figure. well, relatively poor. But thanks to the advanced technologies like noise shaping, dithering, regular signal at 44.16 bits, it can store in about up to 120 decibels. So it's pretty enough for vast majority of cases, but of course 24 bits is a bit better, because 24 bits allows us to get 144 decibels, and without this noise shaping and other stuff. And probably you can understand that 24 bits is more than enough, because even at the full scale with good amplifier, it will cause hearing loss levels. So 32 bits makes no sense. And what about the kilohertz? Actually, we all know that high-res audio should be better and so on. So about the sampling frequency, there is theorem, if I remember right, it's Nyquist-Shannon sampling frequency theorem, and it says that if we sample infinite signal, it's actually important. If we sampling infinite signal, we need to have the sampling rate 2 times higher than the maximum frequency of this signal, and it will be enough for us to restore the original shape of signal. And as you probably know, the highest limit of human ears is about 20 kilohertz, and actually it's degrading with age. So at about 40 years, usually we'll have at max 14 or 15 kilohertz, so it's unavoidable, or maybe almost unavoidable. So anyway, and as you can see, in theory, to 44 kilohertz is enough to store signal with up to 22 kilohertz resolution of sound. So, but actually there are a few different tests conducted. If I will find it, I will put link to the description. And actually scientists in different countries and in different research facilities did some tests, and appeared that people can distinguish the high resolution files. But keep in mind that they didn't say that high resolution sound is better. They just say that average people at proper test conditions, at blind tests, they can distinguish high resolution signal or not. Probably it's because the signal that is above our hearing limit, anyway, it interferes with the lower lying frequencies and we can spot it some way. Actually, our hearing is really sophisticated thing. But anyway, let's go back. So analog to digital converter does its job, and we got some file. So we've got some digital file with our music, and simplest and purest form, it's usually wave files. So it's just that set of measurements, right, and one by one, 2 of them, or 6 if we got 5.1 signal, and so on. But of course wave files are big, so we can do the calculations. So we use 2 bytes multiply 44,000 and multiply 2, and it will be how many bytes we will spend for 1 second, and multiply it by 60. So let me write it down. Probably 2 bytes multiply 44,000 multiply 2 channels multiply 60 seconds. So I can do this calculation in mind, but anyway, you can pause and do the calculation yourself. So anyway, wave files are bigger, so we need to compress them. There are 2 types of compression, lossless and lossy. So lossy compression, it's OGG, MP3, so that formats that are based on the psychoacoustic phenomenons. So for example, after the loud sound we can't, like this train behind my window. So if you hear some loud sound, you won't hear the quiet sound that goes after this sound. So it can be removed from the sound and so on. So MP3 is pretty efficient. So because regular album is about 100 megabytes or even less in MP3 format. And actually I can admit that modern MP3 codecs are not as bad as they considered, because often modern MP3 do a good job in terms of compression, and actually a lot of music won't suffer from the MP3 compression, because usually MP3 codecs most noticeably distort the upper treble, deepest bass, and often reduce dynamic range. But nowadays dynamic range is hugely impacted by the compression, and compression also spoils the treble, so MP3 is not that harmful for the many genres. But of course there are well recorded music that can be totally audible difference because of compression, and that's why we have FLAC. We've got what are other popular lossless codecs, APE and others, so codecs that preserve signal as it is. And actually one of the facts that I wanted to highlight in this talk is that lossy codecs are all equal. So you compress file to FLAC, you compress it to APE, you store it as wave without compression. When it's unpacked, it will be absolutely the same signal. Of course, if decoder is done right and doesn't do any errors. So codecs doesn't matter, lossless codecs, of course. And let's go back to our player. So we've got also, I won't cover DSD this time, it's a bit complicated talk, and I won't cover MQA, it's also a bit complicated talk, but I must admit that actually MQA is lossy codec because it uses sophisticated but lossy compression. So let me try to plot kind of block diagram of typical modern player. So we've got storage with files. Not the best painter. Then CPU read this file and unpack it if it's necessary, or do something with it, and it produces DSD or PCM signal depending on the digital to analog converter. Then it passes this signal to the digital to analog converter, and after the digital to analog converter we've got the analog signal. So here we've got digital, here we've got analog. But usually after the digital to analog converter, this analog signal is pretty weak. So we need to amplify it, and usually we used two amplifiers, preamp and power amp. Sometimes it's called buffer, preamplifier and power amplifier, and here we connect our headphones. So there are different outputs, so we can plug into many places of this process. So first we can output the digital signal just after the CPU unpacking. So we can out it to USB or coaxial. Sometimes also used other connectors, but in players we often got USB and coaxial signal. And coaxial can be optical and sorry, not coaxial, SPDIF. So SPDIF, yes, it's SPDIF, and SPDIF could be optical and coaxial. So let's do it this way. So it can be optical and coaxial. Optical, it's actually with its output with laser beam, and coaxial, it's just electric signal. And as you can probably guess, both of the, or if you know, both of these two outputs, they depends on the quality of the wire used, and they depends on the, actually they depends on the quality of wire, because both optical and coaxial, they are not error prone, and sometimes they can lose signal because of the poor cable. So in this case cables are important, but actually not that important like buy like $3,000 cable. So no, there are a lot of good cables that do their work for $50 or even below. More commonly used, of course, nowadays is USB output. All digital to analog converters can work with USB connection, so all DAPs support that, and FIO is not an exception. So what is important here, if you output the digital signal to the USB or other outputs, all that part of player is not involved. So your digital to analog converter and amplification in the player plays zero role, because digital to analog converter will be used in the device that you will connect. Is it USB? Is it external digital to analog converter, or some receiver, or I don't know, car stereo if they have such inputs, and so on. And another actually option that is also popular nowadays, it's a Bluetooth. So in this case, signal also bypass digital to analog converter, and it's transferred to the Bluetooth chip. Bluetooth chip performs some lossy compression using one of the codecs, so aptX, SBC, LDAC. They are probably the matter of another talk. And what is important here is if this part does nothing with the digital signal, then the quality of the Bluetooth transmission will be the same. So it's not important will it be some expensive player or some smartphone if there is no influence from CPU, because sometimes some manufacturers do something with digital signal. Or if you turn on, for example, equalizer, it will change the digital signal. If you turn some sound enhancer, it will change the digital signal. But in general, if there is no additional enhancers, it's just output digital signal to Bluetooth. It compresses via standard codecs, and that codecs are transmitted wirelessly to the headphones. And digital to analog conversion and amplification will be done on the headphones side. So almost all sources will be equal if they support same codecs. And let's go back. So we can also output analog signal after the pre-amplification. So analog signal, and this part is usually called line out. Line out. Why we need line out? We need it to connect some active speakers, we need them to connect some external power amplifier and passive speakers, and so on and so forth. So usually in many DAPs, line out is combined with regular headphones output, and you just need 3.5mm to the 2 RCA output, and you can connect it to corresponding in. So you connect line out to line in, or sometimes it's called auxiliary in. It depends. If I know right, auxiliary in often named this way in car stereo, for example. So basic logic is simple here. So you connect coaxial or optical out to the coaxial and optical ins of the corresponding device, and line out to line in or auxiliary in. USB to USB, so it's pretty simple. And what remains here, what I want to mention, is actually single-ended and balanced connectors. The one important thing here that you need to know. So typical regular or single-ended 3.5mm connector has 3 pins. So it's left, right, and ground. So it's basically simple. Left wire goes to left, right to right, and ground are united. So if we draw some headphones here, left goes to left, right to right, and both go to ground. So ground wires are connected here. But 2.5 millimeter is using different pinout. It's left plus, left minus, R plus, and R minus. And what is important here, you need not to not short circuit this minus or ground lines. So if you are connecting to the balanced out, never use 3.5 millimeter connector, because it short circuiting these two ground wires, and it can damage your output, or your not your output, your source, your amplifier, player, and other stuff. Of course, there is also Pentacon connector. It has 5. That's named because of that. Pentacon. It has 5 contacts, and actually it has left plus, left minus, right plus, right minus. Not in that, it's not the in order, just I just name them. It has this one, and 5th connector is actually ground, because so sometimes, for example, if I remember right, but it's actually not certain, in Sony devices you can connect 3.5 millimeter connector to their Pentacon out. In that case it will connect to the left plus, right plus, and ground. But it's just for Sony, and actually I'm not sure here. With some other dubs actually uses right minus and left minus, and just 4 poles, and in that case you can also short circuit the output amplification. So anyway, it's better to use the if you want to use a balanced output, and you need to use the balanced wires, so with separate ground. And another topic of discussion, maybe for later, actually balanced output in players, it's not balanced anyway. Just look at the Wikipedia how real balanced audio output works, and it's really different from what we've got in the players. And another thing I wanted to show you is nice and useful site that will help you to select to answer the question, will this amplifier, player, digital to converter be enough for my headphones or no? I will add link to the description, but anyway, let's zoom out a little bit. Really good site. It named Reference Audio Analyzer. They have a lot of measurements actually, but what is even more useful here, they have this nice calculator. So it's SPL calculators. Let's find some headphones. I don't know, like Hi-Fi Man. Made a mistake. Hi-Fi Man Deva. We need full specs. So, does Headphonia have the full specifications about Hi-Fi Man, about Deva, package, design, build quality? Maybe it will be on the last page. It's hard to find the... Headphonia makes good reviews, but I don't remember, do they publish technical specifications? I will be really sad if they didn't do that. Come on, come on. No, it's sad. So that's why I always publish technical specifications. Sorry for taking a bit long, maybe. Porta.Fi, anyone, we need specifications. So here they are, and you need to find some player that you are interested in, like let's take Fios M3 Pro. Of course it's more a joke, but anyway, I want to show you how to interpret the parameters. Take this calculator and we need headphones parameters. So Hi-Fi Man 93.5 decibels. You enter it here, 93.5. And as you can see, there are two types of measurements. So it can be decibels per volt or decibels per milliwatt. And good manufacturers name this measurement parameter. As for Hi-Fi Man, if I remember right, they measure in decibels per milliwatt. Then we need headphones impedance, 18 ohms. Maximum power is not that important here, it's not important for calculations, but usually planar magnetic headphones are pretty good in handling power. And now we need the specs for the player. We need to find its output power. So here it is, 32 ohms, 75 milliwatts for 32 ohms load, and output impedance 0.3. So, where is it? Milliwatts, 75 milliwatts, and 0.3 ohm amplifier impedance. And as you can see, we've got 112 decibels sound performance level. And what does it mean? There is a good table at the Wikipedia with the reference sound performance level. Like 110 is chainsaw and 100 is jackhammer, but of course it's a good example when just this calculator makes no sense, because of course we can understand that it's not enough for this player won't be enough to drive these headphones. But when we're not talking about such extreme cases, of course you can use this calculator to approximate, to make some approximations and some assumptions about how well will some headphones fit, how well some headphones will fit some amplifiers, So it was kind of instruction video from my side. I hope it will be at least a bit helpful and at least a bit understandable. So thank you for listening. Still hope that next time I will have something more viable to tell you. And thank you for listening and have a nice day.